Welcome again to this presentation. Today we are starting a series of questions on the colligative properties of solution. If you want to contact us, you can contact us on this email, and this is also the telephone number. Let's start on question number 1. Question number 1 is saying the vapor pressure of water at 8 degrees Celsius is 355 atol. Calculate the vapor pressure of an aqueous solution made by dissolving 50 grams of ethylene glycol in 50 grams of water. Then they are asking what is the vapor pressure lowering of water in this solution. Let's go to the answer. What do we have? We have the vapor pressure of water, which is the vapor pressure of the pure solvent. It was given as 355 atol. We have also the mass of ethylene glycol, which is the mass of the solute, which is 50 grams. It was given. We have also the mass of the pure solvent. The pure solvent is water. We have also 50 grams of water. Now they're asking to calculate the vapor pressure of an aqueous solution. What is the formula that we use? We know that this formula is saying the vapor pressure of solution is equal to the vapor pressure of the pure solvent times the mole fraction of the pure solvent. So now to calculate the vapor pressure of the solution, we use this formula where the vapor pressure of aqueous solution is equal to the vapor pressure of the pure solvent times the mole fraction of the pure solvent. The vapor pressure of the pure solvent, we have it. This is 355 atol. Then we need to calculate the mole fraction of the pure solvent. And the mole fraction of the pure solvent, which is XA, and the mole fraction we will be using for the solid, we will be using XB. So that means this XA, which is the mole fraction of the pure solvent, is equal to the moles of the pure solvent dividing with the total moles. So we have the mass, we can find the number of moles. The moles of water, which is the moles of water of pure solvent, we have the mass. We divide it with the molar mass. Molar mass of water is 18 grams per mole. Then we get 2.78 mole. We also determine the moles of solid, which is ethylene glycol. We also take the mass of the solid, 50 grams, dividing with the molar mass. The molar mass of ethylene glycol is 62 grams per mole. Then we get the moles of solid, which is the mole of ethylene glycol. Then we determine the total number of moles. We add them. We add this one to this one. Then we get 3.586 mole as the total number of mole. After getting the total number of mole, then we can look the mole fraction of the pure solvent. The mole fraction of the pure solvent will be equal to the moles of the solvent, which is the moles of water, dividing with the total moles. Then after getting the mole fraction of the pure solvent, we have also the vapor pressure of the pure solvent. We can use the formula to calculate the vapor pressure of the solution. The vapor pressure of the solution is equal to the vapor pressure of the pure solvent times the mole fraction of the pure solvent. In this case, we have 275 atol. After getting the vapor pressure of the solution, then they are asking to calculate the vapor pressure lowering. That is the difference between the vapor pressure of the pure solvent and the vapor pressure of the solution. In this case, if we do the difference, we get 80 torrs. That is the answer for question 1. Let's move to question 2. Question 2 is asking to calculate the vapor pressure of a solution made by dissolving 50 grams of calcium chloride. This is the mass of the solid in 5 grams of water, 500 grams of water. So now we have the mass of the solid and we have also the mass of the pure solvent. Then they're asking calculate the vapor pressure lowering. They are giving us the vapor pressure of pure water, which is 47.1 torr at this temperature. Let's see the answer. we will use the same formula, but we have calcium chloride in solution. It will not be a single, it will be having two ions, it will be having calcium 2 plus, and it will be having chlorine minus. That means here we have two solutes in solution. So we have the vapor pressure of solution, which is equal to the vapor pressure of the pure solvent times the mole fraction of the pure solvent. What do we have here? We have the vapor pressure of the pure solvent, which is 47.1. Now we need to determine the vapor pressure of the solution. But before determining the vapor pressure of the solution, we need also the mole fraction of the solvent. So to determine the mole fraction of the solvent, we need to take the moles of the solvent dividing with the total moles. So moles of water, we determine the moles of water, we take the mass of water, which is 500 grams, dividing with the molar mass, we get this moles of water. Then we determine the moles of calcium chloride, we obtain 0.45 moles, but calcium chloride in water will dissociate to give a calcium 2 plus and 2 moles of chloride, 2 moles of chloride ion. In this case, then we can determine the concentration or the moles of calcium 2 plus and the moles of chloride. In this case, we have 0.45 moles of calcium 2 plus and 0.9 moles of chloride, because if you can check in the equation, you have 2 moles. Chloride ion is 2 moles. That means you have 2 double the concentration, or 2 double the moles of calcium, or 2 double the moles of calcium chloride. So then in solution we have 0.45 moles of calcium. We have also 0.9 moles of chloride. We have also we have also 27.7 moles of water. Then we can determine the total moles. In determination of the total moles, we need to add this one. We need to add this one for calcium, and we add also this one for chloride. The total moles, we have 27.7 plus 0.45 plus 0.9. Then we get the total mole is equal to 29.05. After getting the total moles, then we determine the mole fraction of the pure solvent by taking the moles of pure solvent, the moles of water, which is 27.7, dividing with the total moles. Then we will get this mole fraction as mole fraction of the pure solvent. Then we can determine the vapor pressure of the solution by taking the vapor pressure of the pure solvent times the mole fraction of the pure solvent, and we get 44.88 Torr. For vapor pressure lowering, we need to do the difference between the vapor pressures. In this case, we take the vapor pressure of the pure solvent minus the vapor pressure of the solution. Then we will get the vapor pressure lowering of 2.22 Torr. Question number 3. Question number 3 is saying, at 25 degrees Celsius, the vapor pressure of the pure benzene is 93.9 Torr. That means you have the vapor pressure of the pure solvent, which is 93.9 Torr. Then they are saying when a non-volatile solid is dissolved in benzene, that means benzene is a pure solvent, then they are adding a non-volatile solid. The vapor pressure of the benzene is lowered to 91.5 Torr. That means it is lowered to, that means we have the vapor pressure of the solution after adding the non-volatile solid. Then they are asking what is the vapor pressure lowering. They are asking also what is the concentration of the solid and the solvent expressed in mole fraction. Here what we have the P naught, which is the vapor pressure of the pure solvent. We have also the vapor pressure of the solution. We can determine the vapor pressure lowering by doing the difference in vapor pressure. In this case, we have 2.4 Torr. So after getting the vapor pressure lowering, we need also to calculate the concentration of the solid and the solvent. So in terms of the mole fraction, we need to see this formula. This one we have, this one we have. Then we can determine the mole fraction of the pure solvent by taking the vapor pressure of the solution dividing with the vapor pressure of the pure solvent. Then after getting the mole fraction of the pure solvent by taking the vapor pressure of the solution dividing with the vapor pressure of the pure solvent, we get the mole fraction of the pure solvent. And after getting this mole fraction, we can determine the mole fraction of the solid, because we know that the mole fraction of the solid plus the mole fraction of the pure solvent should be equal to 1. Then that means the mole fraction of the solid is equal to 1 minus the mole fraction of the pure solvent. So in this case, we get XB, that's the mole fraction of the solid, is equal to 1 minus 0.974. Then we get 0.026, because they were asking to determine the concentration of the solid and solvent expressed in mole fraction. That means for the solid we have 0.026 mole fraction, and for the pure solvent you have 0.974 as the mole fraction. Let's go to another question, which is question 4. Question 4 is also asking to determine the vapor pressure lowering, and also to calculate the relative vapor pressure and to calculate the relative vapor pressure lowering. What was given? We have the vapor pressure of pure liquid, which is this Newton per meter squared. So that means here we have the vapor pressure of the pure solvent. They are saying when a non-volatile solid is dissolved, the vapor pressure becomes, so that means you have also the vapor pressure of the solution. Then to calculate the vapor pressure lowering, we do the difference. Calculate the relative vapor pressure, that means the vapor pressure of the solution relative to the vapor pressure of the pure solvent. Then they ask me to calculate the relative lowering of the vapor pressure. Also, we take the lowering of vapor pressure relative to the vapor pressure of the pure solvent. Let's go quickly to the answer. In this case, the vapor pressure lowering, this is the difference in the vapor pressure. We have this value as the vapor pressure lowering. Then we have the relative vapor pressure lowering. In this case, we take the vapor pressure of the solution dividing with the vapor pressure of the pure solvent. Then we get this one. Then we have also to calculate the relative lowering of vapor pressure. Relative lowering of vapor pressure, we take the difference in the vapor pressures dividing with the vapor pressure of the pure solvent. Then you will get this value. Let's go to question number 5. Question number 5 has two sub-questions. We have sub-question A and sub-question B. Let's see, the sub-question A is saying, at this temperature, the pure water has a vapor pressure of 31.1 Torr. That means you have a vapor pressure of the pure solvent. Then they are saying a solution is prepared by adding 86.8 grams of this compound X. That means the compound X is unknown, but we know the mass of the compound X as 86.8. Then we know also the mass of the pure solvent, which is the water. That means the mass of the pure solvent is equal to 350 grams of water. That's the mass of the pure solvent. They are saying also X is a non-volatile non-electrolyte. That means this unknown compound will not be going to dissociate into the water. The vapor pressure of the resulting solution was given as 28.6 Torr. Then calculate the molar mass of the compound. So we need to use the formula again to calculate the vapor pressure of the solution. Then we will rearrange to find the molar mass. Here we have the mass of the solid. We have also the mass of the solvent. We have also the vapor pressure of the pure solvent and the vapor pressure of the solution. Then we can determine the moles of the solvent by taking the mass of the solvent dividing with the molar mass of the solvent, because the solvent is water. We can also determine the molar mass of the solid by using this formula, which says the molar mass of solid is equal to the mass dividing with the number of moles. So that means If now the number of mole is equal to mass over the molar mass, that means the molar mass is equal to the mass dividing with the number of mole. So what do we have? We have the mass of the solid. Yes, it was given as 86.8 gram. This is the mass of the solid we have, but we don't have the number of mole of the solid. For us to get the number of mole of the solid, we should rely on the mole fraction. You can get the mole fraction of the solid. What we have now, we have the moles of the solvent, and you can determine the mole fraction of the pure solvent if we have the vapor pressure of the pure solvent and the vapor pressure of the solution. So that means this XA, which is the mole fraction of the pure solvent, will be equal to the vapor pressure of the solution dividing with the vapor pressure of the pure solvent. Then we get the mole fraction of the pure solvent. After getting the mole fraction of the pure solvent, we determine the mole fraction of the solid by taking 1 minus the mole fraction of the pure solvent. We get 0.08 as the mole fraction of the solid. After getting the mole fraction of the solid, we know that the mole fraction of the solid is equal to the moles of solid dividing with mole of solid plus mole of solvent. That means mole of solid dividing with the total number of mole. Now, what you are looking for is the mole of solid, so that we can determine the molar mass of the solid. After getting the mole of solid, we immediately take the mass of solid dividing with the number of moles. Then we get the molar mass of the solid. So we know this XB is 0.08, which is the mole fraction of the solid. Then you can rearrange by taking this one. This one, it is known, the mole fraction of the solvent. Then if we arrange, we can determine the mole of solid. We see that the mole of solid is equal to 1.696 mole. Just rearrange and find the mole of solid. Then after getting the mole of solid, you can determine the molar mass of compound by taking the mass dividing with the number of moles. Then we will get 51.18 gram per mole. That was question 5A. Let's move to question 5B. Question 5B is saying the vapor pressure of the solution containing this mass of the solid in 0.1 kilogram of water. That means you have the mass of solid and you have also the mass of the pure solvent, which is the water. You have also the vapor pressure of the solution, which is 27.371 millimeter mercury. Given the vapor pressure of water, that means you have also the vapor pressure of the pure solvent as 28.065 millimeter mercury. They are asking derive the formula to calculate the molar mass when moles of solid are negligible as compared to the moles of solvent. Remember, in equation 5A, we didn't make the moles of a solid as negligible, but here they are asking if we consider the moles of solid as negligible as compared to the moles of the solvent. Then they're asking, we derive the formula to calculate the molar mass of the solid. Then they are saying using the formula, we calculate the molar mass of the solid by having the data. Let's see, we also rely on the first formula that we have used, saying that the vapor pressure of the solution is equal to the vapor pressure of the pure solvent times the mole fraction of the pure solvent. Then in this case, we know that the mole fraction of the pure solvent plus the mole fraction of the solid is equal to 1. That means the mole fraction of the pure solvent is equal to 1 minus the mole fraction of the solid. Then we can replace this one into this formula. In this case, we get if after replacement, we get the vapor pressure of the solution. We are replacing the XA by its value. Then, in this case, we can multiply this one to this one and multiply this one to this one. Then we get the P equal to P naught negative P naught XB. If we can rearrange, then we push this one here. We get P minus P naught. That means the vapor pressure of the solution minus the vapor pressure of the pure solvent is equal to this value, this formula. In this case, if we can put it, we can multiply for negative, here multiply for negative, here multiply negative, that here it becomes positive, and there it becomes P minus PO minus P. PO minus P is equal to this one. So we multiply negative here and negative here on both sides. That means that XB, you can find the XB, which is the molar fraction of the solid, as equal to P naught minus P over P. That means the molar fraction of the solid is equal to the pressure of the pure solvent minus the vapor pressure of the solution dividing with the vapor pressure of the pure solvent. Molar fraction of the solid is equal to the vapor pressure of the pure solvent minus the vapor pressure of the solution dividing with the vapor pressure of the pure solvent. That is so far the first formula that we have. We can get the molar fraction of the solid. Then let's use another formula. We know that the molar fraction of the solid, again, is equal to the number of mole of the solid dividing with the total number of mole. That means the number of mole of the pure solvent plus the number of mole of the solid. If we can then replace the number of mole by mass over the molar mass, because we know the number of mole is equal to mass over the molar mass, here it will be the mass of a solid over molar mass of solid, mass of the solvent over the molar mass of the solvent plus the mass of the solid over the molar mass of the solid. Then they are saying for diluted solution, because they are saying we need to consider that the moles of solid are negligible. That means this term becomes negligible because these are the moles of solid. We make negligible this term as compared to this term. That means if you add this term, this one, you always get this term. So then we make negligible for diluted solution. Then in this case, after making the term in red negligible, we get this formula, XB is equal to this value. That means it's equal to this formula, MB, which is the mass of the solid times the molar mass of the pure solvent dividing with the molar mass of the solid times the mass of the pure solvent. We have now the formula to calculate the XB, which is this one. We have the formula, this one that we got right now, which is this one. We have also the one we have derived to calculate the mole fraction of solid in terms of the vapor pressures. Then we can equalize the two formulas. After equalizing the two formulas, then we can determine the MMB, which is the molar mass of the solid. After the arrangement, we do the arrangement, we will see that the molar mass of the solid will be equal to the vapor pressure of the pure solvent times the mass of the solid times the molar mass of the pure solvent dividing with the change, the difference in the vapor pressure. That means the vapor pressure of the pure solvent minus the vapor pressure of the solution times the MR, which is the mass of the pure solvent. This is the formula that they were asking to derive. Then we can use the formula again to calculate the molar mass of the solid based on what they have, the data that were given in the question. Let's now use the formula. So the data that were given in the question, you have this one, the MOB, which is the mass of the solid. We have also the mass of the pure solvent, which is water, and you have the vapor pressure of the pure vapor pressure of the pure solvent and the vapor pressure of solution. You can put the PA or PA naught. So here we are putting P naught. Here they have put PA naught, but not it's the same as P this one. Don't get confused. This PA naught is the same as this one. That means it is the vapor pressure of the pure solvent was given, and here also we have the vapor pressure of solution. Then we put the values. Then we will see that we get 94.63 gram per mole as the molar mass of the solid.